Okay. Question number 1, part B, quadratic equation. Given that x squared plus ax plus b equals 0, it has a roots alpha beta. This equation has a roots alpha beta. Obtain the quadratic equation 1 squared alpha squared and 1 squared beta squared as its roots. Right. So then the sum of the roots and product of the roots we can write. Sum of the roots going to be simple A, product of the roots is B. We get 5 marks for this. Next one, equation with the roots. Equation with the roots 1 over alpha squared and 1 over beta squared is, we can write what? X squared minus, first add the two roots within bracket, x, right, product of the roots 0, right, for these 5 marks. And here we can simplify alpha squared plus beta squared and denominator alpha beta perfect squared, and here alpha beta perfect squared equals 0. That also you get another 5 marks. And then this one you can write here. This question is a little bit shorter, therefore more marks come into this part. Right, this way. Okay, alpha squared plus beta squared we can write like this: alpha plus beta perfect squared minus 2 alpha beta. Yes, for that also another 5 marks you get. Okay, and now you can substitute for this alpha beta part, x squared alpha plus beta a squared minus 2b, and denominator beta squared is b squared times 6 plus 1 over b squared equals 0, no? For that 5 marks, and multiplying this by b squared, we get the last equation, b squared x squared minus a squared minus 2b x plus 1 equals 0. The last 5 marks you get, right? So this way, for this question, you get unusual marks for most of the steps. That is because of this question is shorter, more marks available. Then this way, marks offered, right? Right. Now, next one I'm asking, hence deduce the quadratic equation. Hence means using this, right? You know, in this equation, the two roots are, one root is 1 over alpha squared, other is 1 over beta squared. The two roots are these two. Okay, the two roots are these two. Okay, so then the asking the quadratic equation with the roots 2 beta squared plus 5 over alpha squared and 2 alpha squared plus 5 over beta squared. The quadratic equation with the roots this and this. Asking using this equation. Hence means that. So this time you know the two roots are symmetric, no? When we interchange alpha beta by one root, we get the other. That occasion we know how to obtain. We take n root we like as y. All right. Now let us take this one as y. Let y equals 2 beta squared plus 5 over alpha squared. Then take common denominator as alpha squared. Then alpha squared beta squared come in here. That is nothing but alpha beta perfect squared plus 5. Okay. For this, you get 5 marks. And now alpha beta is the product B, right? Then we get y equals b squared plus 5 over alpha squared. We'll bring this pair here. Then we can subject alpha squared, 1 over alpha squared equals, okay, 1 over alpha squared equals y over b squared plus 5. 1 over 2b squared, no? Here, 2 we have 2b squared, 2b squared plus 5. Okay, for that also 5 marks. Okay, now 1 over alpha squared is the root of this. Therefore, 1 over alpha squared should satisfy this equation, no? Then we can substitute that. Hmm? Since 1 over alpha squared is a root of the above equation. Above equation, we can write b squared. For this x, we can put what? 1 over alpha squared. For this x, you can put, not x squared. For x, because roots of this equation as 1 over alpha squared, 1 over beta squared. Right. So therefore, for x, we can put 1 over alpha squared. Then 1 over alpha squared is this. Then I can put y over 2b squared plus 5 to the power 2. Right. Okay. Minus a squared minus 2b y over 2b squared plus 5. And plus 1 equals 0. Right. If you go through another way, no marks. The reason? The word hence given there, right? So then in this case, you must take the quadratic equation in y. So then I multiply. This is 5 marks. And now we multiply this by hmm? Right. It's perfect square by we multiply this. Then we get here b squared y squared and a squared minus 2b times 2b squared plus 5y and 2b squared plus 5 perfect squared equals 0 is the required quadratic equation, no? Yes. Okay, this is the required quadratic equation. Do we need to change this y to x? No. Even though we keep in terms of y, it's still correct. Or you put x for y, still okay. Right. Here, another 5 marks. Part B. Okay, find lambda mu nu such that this happens 1 over x into b, 1 bx is here. So here lambda 1 minus ax mu 1 minus bx nu 1 minus ex. Right. We multiply both sides by 1 minus ax, 1 minus bx, 1 minus cx. Then here we get 1 lambda times 1 minus bx, 1 minus cx, mu times 1 minus ax, 1 minus cx, nu times 1 minus ax, 1 minus bx. Right. For this 5 marks. Okay. We put x equals 1 over b. Then this 1 minus bx factors will cancel, right? Then we get the answer for mu, right? Okay. Then we get mu 1 minus a 1 over b 1 minus c 1 over b. Right. For this 5 marks, by simplifying this, you get mu equals this answer b squared over b minus alpha b minus a, not alpha, b minus a b minus c. Right. Okay. For this, another 5 marks. Right now, put in like that x over 1, x equals 1 over a, you get lambda. Right. So then I'm not going to write that step here. So once you put x equals 1 over a, this 1 minus ax factor will be 0. Then we get the answer for lambda, right? The answer of lambda coming, right? So then similar steps we get here like this for that 5 marks. I'm not going to write the substitution, no, you can write. Then answer of lambda coming a squared over a minus b a minus c. For this another 5 marks. Correct, no? And next one we put x equals 1 over c. Then the factor 1 minus ex will be 0. Then we get the answer for nu. Then also the first line this way we get, and for that you get 5 marks. And the answer of nu come in c squared divided by c minus a, c minus b. This is another 5 marks. These substitutions we can do, no point of writing them. Then we can substitute for lambda, mu, and nu. We are here. Here, for the places of lambda, mu, and nu, we substitute what? That found answers. That found answers we substitute. For that found answers, we substitute lambda, mu, and nu values. Okay. Then we get 1 over 1 minus ax into 1 minus bx, 1 minus cx. Equals lambda, this answer. Then we get a squared, right, divided by a minus b, a minus c, right? For the lambda, we substitute this answer here. A minus b minus c. That is lambda value. And this 1 over 1 minus ax. Right. Now I erase this. And mu b squared over this, u squared over b minus c, 1 over 1 minus bx. Nu u squared over c minus a, c minus b. 1 over 1 minus ex. This way we take. Right. This is for this substitution 5 marks. Because this substitution is required to take the next answer. Right. Now, hence reduce. Hence reduce means this result must be used. What is this result? Left and right equal for any value of x, no? Really, we found the partial fraction of this, no? The partial fraction of this only right hand side we have. Then the same expression only we have on the right hand side. So that means they are equal for all values of x. This is therefore an identity. And then we put any value for x. The best value to put in this case to take the answer is x equals 0. Put x equals 0 on both sides. Put x equals 0. This 0, this 0, this 0, we get 1. A squared over a minus b, a minus c, b squared over b minus a, b minus c, c squared over c minus a, c minus b. We get now for this 10 marks. This is how we take the answer. Right, question number 2 next. Yes, it says using the first principle, find the first derivative of y equals 1 over 1 minus x. Make it. Yes, first principle, find the first derivative of y equals 1 over 1 minus x. Ask you to take the answer using the first principle. Some people, they just differentiated and gave the answer. No marks. First principle means using the definition of delta x. That way we have to follow. Can remember the definition of 2 part a y equals 1 over 1 minus x. No. Then dy by dx we can write limit delta x equals 0. How to write this, people? First, this x should be replaced by what? X plus delta x, no? Right? 1 minus every x we replace by x plus delta x. And thereafter, the same function we have to subtract this way. Right? And that should be divided by delta x. Correct, no? The right hand side x replaced by x plus delta x, and minus same right angle, okay, right hand side. So now for these 5 marks come in, right? We take the product of these two as the common denominator. One minus x minus 1 minus x plus delta x, one minus x plus delta x into 1 minus x delta x. These two you can cancel down, no? For the simplification, 5 marks. Now dy by dx, limit delta x going to 0. Here minus plus x minus x. That 2 we can cancel down. Then we get minus plus delta x. That plus delta x we can cancel down with this. Okay. Then we get finally we get minus plus 1, no? Right. Numerator we get 1. Because this delta x cancel with the denominator delta x. Then we get numerator 1. 1 over 1 minus x plus delta x, 1 minus x. For this 5 marks, huh? Then put delta x 0. Here we get 1 minus x, here we get 1 minus x. This is nothing but 1 minus x squared, no? dy over dx is therefore 1 over 1 minus x perfect squared. For this 10 marks. Given that y equals sin inverse x divided by square root of 1 minus x squared. Right. Y equals sin inverse x over square root of 1 minus x squared, right? So then we'll differentiate this by using u upon v form. Right. First we have to square the denominator, root will eliminate. Same square root we must write at the numerator. Sin inverse x derivative is square root of 1 over square root of 1 minus x squared minus sin inverse x, right? Derivative of this root, what is that? 1 over 2 times the same into derivative inside that, no? Yes. 1 over 2 times the same, right? 1 over 2 times the same inside the root sign derivative is minus 2x. Okay. Here marks come in for this 5. For this 5. For this 5. Huh? So here cancellation can be done. This and this we can cancel down. These two we can cancel down. Then what you have is dy over dx. Use the cross multiplication to this left hand side. 1 minus x squared. Okay, dy by dx equals here 1 minus this minus and that minus make plus, no? Here this minus x. Here we have Sin of 6, sin of 6 divided by square root of 1 minus x squared is y. 1 plus xy coming. So that 10 marks coming now. 10 marks. Right. Second one asking second derivative. Differentiate this again. What is that? 1 minus x squared dy over dx equals 1 plus xy. No. Right. We differentiate this again. Here you have to apply u into v. 1 minus x squared we have to keep as the same. Here second derivative. And here keep the dy by dx as the same. Here minus 2x. 1 is a constant alone, derivative 0. Here apply again uv, x into dy by dx plus y into 1. So for each 5 marks coming here, 5 marks, here 5 marks, here 5 marks, here 5 marks, altogether 20 marks. Then here we get the answer. Minus 2x dy over dx, that to take left hand side, minus 3x dy by dx, 1 minus x squared, and d2y over dx2 minus 3x dy over dx. Okay. And y, no? Yes. Then this is nothing but. So the answer, another 10 marks coming for that. Okay. Next one asking, find the value of dy by dx and d2y over dx2 at x equals 0. Right. So then we have to first find at x equals 0 y. Right. At x equals 0 y. Y means sin inverse x upon this, no? Y sin inverse x over square root of 1 minus x squared, no? Y. Put x0 here, sin inverse 0 is 0, numerator 0, denominator 1, y is 0. We need this 5 marks for that. And I take now first answer, this one. Now using 1 minus x squared dy over dx equals 1 plus xy, right? We'll put x0 here. Put x0. Then this bracket is 1. This is the dy by dx. Its value x equals 0. We write it like this. Right hand side, when you put x0, this product will be 0. We get 1. Then we get dy by dx at x equals 0 as 1. Dy by dx at x equals 0 equals 1. You get 5 marks for this. Right. Secondly, we put x equals 0 here. Right. Put x equals 0 where? In this one. 1 minus x squared. Second derivative. Minus 3x dy over dx equals y. Right. So then you know when you put x equals 0, this entire thing will be 0. When x equals 0, y also 0. Then this is 1. Then second derivative becomes 0 at x equals 0. For this we get another 5 marks. Right, next one. Okay, the wireframe shown in the diagram. Yes, that one, no? Length of the side. Yeah, triangle X. They are equilateral triangles, huh? Equilateral triangles. Right. Okay. Okay, I'll take this side as y, x, 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 x. Right? Okay, what is asking there? The length of the wireframe is L. So that the area of the frame is area. Hmm? These three are equal, equilateral triangle, no? Okay. Then, if I produce, if I drop a perpendicular from this vertex to this, okay, the perpendicular foot will be at the midpoint of this side, this way. It's going to be x by 2 because this is an equilateral triangle, and also this angle 30. This also 30. This angle is bisected by the perpendicular. Right. So then first we can write perimeter x6, x6, 4x plus 2y is the total length. Hmm? L equals 4x plus 2y equals L. Okay. Then we can subject y L minus 4x by 2. Hmm? For these 5 marks. Now we write area I. Right. This area plus this area, this area. This area multiplied by 2, no? Area of triangle is what? Half base x, perpendicular height is x cos 30. Cos 30 is root 3 by 2. There are two such triangles multiplied by 2. Okay, plus xy, 5 marks. Then here, a, these two you can cancel down. Root 3, x squared over 2 plus x into, y is this? L minus 4x divided by 2. Then this gives us the A answer. Lx there. Hmm. X squared we can take out. Root 3 minus 4 x squared. For this 10 marks. Find the value of x which maximizes the area. Hmm? We'll differentiate this now. dA over dx. This 2 is constant. Keep it as half. Lx derivative with respect to x is L. Root 3 minus 4 is a constant. 2x. Right. For that, 5 marks. Then I can write dA over dx, the right hand side. Yes, this way, minus 4 minus root 3. X minus, this way I can write L over 2 times 4 minus root 3. This is taken, really taking this minus sign 4 minus root 3. That means root 3 minus 4 we take out. This one we take out. Then we get this. Right, there's nothing. Okay, now up to here, writing this, we get another 5 marks. Now, for maximum or minimum A, you know dA over dx equals 0. For maximum or minimum A, dA over dx for maximum or minimum A, dA over dx should be equal to what? 0. Should be equal to 0. Right. Once we equate this right hand side to 0, since this is not equal to 0, this bracket should be 0. Therefore, we get what? X equals L over 2 times 4 minus root 3. For this 5 marks. Then we find the sign of dA over dx. X less than L over 4 minus root 3. That means what? We substitute for x a value. For this, we substitute a value which is less than this. Then this is negative, but here also we have negative. Then we have positive sign, no? Positive. And dA or dx we find after this x value. Then we get this is negative. Positive, 0, negative means maximum, no? Therefore, A is maximum. Here, 5 marks here. 5 marks. Then you can write, therefore, A is maximum. Other 5 marks. Then asking A max. Maximum value of A also asking, no? It is the maximum value of the area of the wireframe. Right. So A max we need. Right. Right. There we get expression for A is this, A max. Of L, you know, A is maximized by x value this. Then that x value only we have substitute in that expression. Every x should be replaced by this answer. Right. This now L times substitute for x this 2 times 4 minus root 3. Right. Plus root 3 minus 4 x squared. X squared means this. L squared over 2 times 4 minus root 3 perfect square. The substitution 5 marks. Simplify and take this answer you get. I didn't simplify that. It is coming 182 perfect squared. Yes, substitute for L 182, right? Because L given as 182, no? 182 perfect squared divided by 8 into 4 minus root 3, right, for this 5 marks. Huh? For the whole question, 150 marks come in. Huh? Next one, the question number 3, the trigonometry question. Question number 3, part A. Given that f theta equals cos theta into sin squared theta by 2, given theta less than pi greater than 0. Ask and write, find ABC such that f theta equals this, right? Okay. We know half angle formula we can write for cos theta 1 minus 2 sin square theta by 2, subject sin square theta by 2 by this 1 minus cos theta by 2. Huh? All right. So then we can substitute for this cos theta. 1 minus cos theta by 2. 5 marks. Huh? Bring this cos theta inside. F theta. It is, I take minus sign also out. Cos theta, cos theta. Cos square theta minus cos theta. Right. Now here, complete the square of this. Completing the square mean what? Of the square term, we take without the square. And this term coefficient should be divided by 2 minus half. Then always we subtract perfect square of this second term, 104. But for this 5 marks. For this 5 marks. Now remove the bracket, this and this. F theta equals 108 minus half cos theta minus half perfect square. Cos theta minus half perfect square. Okay. For this 5 marks. Now we have to find ABC now. We compare this with what? F theta A minus B cos theta minus C perfect square. No. Then A 108, B half, C 105. Oh, this way 5 marks. Huh? Okay, next part given this way. ABC, in the triangle ABC in usual notation, if cos A into sin squared A by 2, cos B into sin squared B by 2, cos C into sin squared C by 2 equals 3 by 8, show that ABC is an equilateral triangle. Huh? Equilateral triangle. Yes. Who did this question? Huh? Shavani did this question? No. Amra? You did this question in the paper? You did? Shasha. Right, good. Okay, now next part is this, no? Cos A cos A into sin squared A by 2, cos B into sin squared B by 2, cos C into sin squared C by 2 equals 3 by 8. Okay, here we just now found the cos theta into sin squared theta by 2 in this theory here. Cos theta into sin squared theta by 2, right? We can write like this. The same form here we have, no? Instead of theta here we have A. Then for this, and for this, all these three, we can write similar form like this. Right. What is that? 1 over 8 minus half cos A minus half perfect square. 1 over 8 minus half cos B minus half perfect square. 1 over 8 minus half cos C minus half perfect square equals 3 by 8. You can very clearly see there. Here 1 upon 8 plus 1 upon 8 plus 1 upon 8 is 3 upon 8. The 3 upon 8, once you take right hand side, can be cancelled down with this. Right. Now, these three terms, square terms only, we have right hand side, we have 0. Okay. Then this minus half, you can cancel down. Correct, no? Then we get what? Cos A minus half perfect square, cos B minus half perfect square, cos C minus half perfect square equals 0. Right. Here, for this 5 marks, get in this 5 marks. Okay. You can see sum of 3 squares. This is a square, this is a square, that's a square. Their sum is equal to 0. Right. Then always a perfect square is positive of 0. Then these 3 perfect squares, when we add, if the answer is 0, for this to happen, each perfect square should be 0. Yes. This gives us what? This should be 0. That means cos A should be half, right? And cos, cos B should be half, and cos C should be half. Not O should be end. Each should be occurred. Here, A 5 by 3 and B 5 by 3 and C 5 by 3. Hmm? And then what can we say? The triangle ABC is, therefore the triangle ABC is equilateral triangle. Therefore, ABC triangle is an equilateral triangle. For this 5 marks. For the last statement. Right now. Next one, fx. Fx 1 plus cot x divided by 1 plus cot squared x. X in between pi by 2 and minus pi by 2. Hmm? Right, 1 plus cot squared x is what? Cot 1 plus cot squared x is cosec squared x. Right. Cosec squared x means what? 1 over sine squared x. That sine squared x we can write numerator. If x equals sine squared x, now 1 plus cot x means cos x by sine x. Huh? Now bring this inside. Sine squared x plus, once you bring here, that becomes sine x cos x. Okay. All right. For this, we get 5 marks. Right. But you know, cos 2x, we can write this, you know. Cos 2x is what? 1 minus 2 sine squared x. Bring this side. Sine squared x equals 1 minus cos 2x by 2. Now put that pair here. This sine x cos x, we multiply by 2 and divide by 2. X 1 minus cos 2x by 2 and sine 2x by 2. 5 marks, right? Okay. Then here 1 by 2 we have. We take that first. And cos 2x divided by 2, sine 2x divided by 2, we take half out with minus sign. Then this becomes plus cos 2x minus sine 2x. This way we get. All right. Here, 1 available here, 1 available here. Then 1 squared plus 1 squared is 2. Its root is root 2. We divide by root 2 and multiply by root 2. Fx half multiplied by root 2 divided by root 2. And you say fx. Here 1 over root 2 coming. Right. We can write this 1 over root 2 as cos pi by 4. The second 1 over root 2 we can write as sine pi by 4. Then this is really cos a plus b, no? Fx is equal to half minus 1 over root 2 cos 2x plus pi by 4. Then we can rewrite this way. This half I write last like this. Okay. Then for this 5 marks coming, for this other 5 marks coming. When you compare this with the given, hmm, right? When we compare this, what you get there effects 1 minus 1 over root 2 cos 2x plus pi by 4 plus half. Right? It is given as fx a cos 2x plus alpha plus b. Right? Now compare a minus 1 over root 2 alpha pi by 4. We have a minus 1 over root 2 b half alpha pi by 4 for this another 5 marks. Yes. Okay. Now what is asking next? Next one asking. Hence draw the graph of y equals 2fx for this 2fx asking, no? Asking to sketch the graph. 2fx asking. In my marking, I have sketched graph fx. Anyway, 2fx also asking. Right. In my marking, I have sketched the graph of fx. Right. Okay. 2fx we need, yes. Right. Y equals 2fx we need to sketch 2 times for the fx substitute that what minus 1 over root 2 cos 2x plus pi by 4 plus half. Then here we get y minus root 2 cos 2x plus pi by 4 plus 1. Right. We need to sketch the graph in the interval minus pi by 2 and plus pi by 2, right? Okay, in this interval. Right. Y equals 2fx is asking, right? First put x equals pi by 2. What is y? Minus root 2. Here what do you get? When you put 90 here, 180. Cos 180 plus pi by 4 means minus cos pi by 4, no? Put 180 here. Sorry, 90 here. 2 into 90, 180. Cos 180 plus theta minus cos theta minus cos pi by 4. 1 over root 2 plus 1. This and this we can cancel down. Y equals 2. X equals pi by 2. Y equals 2. X equals minus pi by 2. Let's see what happens. Y. Minus 2 cos minus 180 plus pi by 4. Minus 180 plus pi by 4 plus 1. Right? You know, again, inside the bracket, this angle we can take, we have minus sign now, we can take minus, and inside the same angle we can write. Then we get cos minus, inside the bracket, 180 minus pi by 4. You know, cos minus theta is cos theta. Then this becomes cos 180 minus pi by 4. Cos 180 minus pi by 4 is again minus cos pi by 4. Therefore, we get here minus root 2, right? Minus cos pi by 4 is 1 over root 2 plus 1. This is nothing but again 2. Right. So this and this 5 marks. 5 marks. Right. Right. Fx max. All right. Right. Now this time fx to be maximum. This cos 2x plus pi by 4 should be minimum, no? 1 minus this is fx. Then for the maximum y, it should be minimum, no? Because we have minus sign here. Fx max going to be what, people, then? Here, it should be minus 1. Then minus 1 minus root 2 is root 2 plus 1, no? 1 plus root 2. This happens when cos 2x plus pi by 4 is equal to minus 1. Right. Okay. Right. So then tell me, for what angles cos becomes minus 1? 180. And minus 180. Okay. 180 and minus 180. Yes. Then equate this angle pi by 4 to 180 and the same angle to minus 180. So when you simplify this, we get x equals 3 pi by 8. This is in our interval between minus 90 and plus 90. When you take this right and simplify, this going out from the interval. This is not in the range. We must know the graph in the interval minus 90 plus 90, no? But this x gives not in the interval. Therefore, no point of finding that. All right. Then fx max is 1 plus root 2. X is 3 pi by 8. Right. So then this and this, we get another 5 marks. Fx max, we found fx minimum now. Fx minimum. For fx to be minimum, okay, 1 minus something. Then the answer y should be minimum. Then this subtracting amount should be maximum. Subtracting amount to be maximum, this cos 2x plus pi by 4 should be maximum. Its value is 1. Then y minimum is what? 1 minus root 2. 1 minus root 2. Correct, no? 1 minus root 2, yes. Then the corresponding angle come in. This happens when cos 2x plus pi by 4 should be equal to 1. For cos angle to be 1, the angle should be 0. Angle should be 0. Or what? Angle should be 0 or 2 pi. When 2 pi we write there, the angle is going to be out of the interval minus 90 plus 90. So therefore, this gives us only one angle minus pi by 8. Right. For this two also, another 5 marks coming now. Other 5 marks coming, right. So next one, we need to find the points where graph cuts the x-axis. Sorry, y-axis. When x equals 0, you can write. When x equals 0. When x equals 0, when x equals 0, what do you get there? When x equals 0 here, 2x plus pi by 4, no? Cos pi by 4, 1 over root 2, root 2, root 2. We can cancel down. 1 minus 1, 0, y 0. Y 0, right? X equals 0, y 0 means graph passing through where? Graph passing through origin. Graph passing through the origin, right? Next one, the points where graph cuts the x-axis, put fx 0. When fx 0. When fx 0 mean this. Then we get cos 2x plus pi by 4, right? Take this to this side, right? Take this to this side, okay? Then that becomes plus, no? Equals 1 over root 2, okay? Right? Cos angle equal to 1 over root 2. What should be the angle? Cos 45, 1 over root 2. Cos minus 45 also, 1 over root 2. Am I correct? Okay. 2x plus pi by 4 equals pi by 4. This gives x equals 0. That we know already. What is the other possibility to get 1 over root 2? 2x plus pi by 4. 2x plus pi by 4 should be equal to minus pi by 4. All right. Minus pi by 2. X equals minus pi by 4. Correct, no? Okay. Then for this also, 5 marks. Right now we can sketch the graph. Yeah, right. All the data related to this graph we now found. Here minus pi by 2 minus x-axis plus pi by 2 axis. Here y minus 5. 2 here, 1 plus root 2 here. Maximum value, minimum value, 1 minus root 2 minus something, no? Right. Here minus pi by 4. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . 5 by 4, 3 pi by 8, 5 by 8. Correct, no? Right. Here, when x equals minus pi by 2, y2 by 2. Here 0. Here minimum value happens minus pi by 8. Minus pi by 8 is here. Passing through the origin. This point, this point, this point, passing through the origin. Maximum happens when 3 pi by 8, no? Yes. 3 pi by 8 is this. This here. And at pi by 2, it's 2. Right. Now we can sketch the graph. For the graph, 10 marks coming now. There are many things to find, but when you practice this, very easily we can find that. This is the complete graph. 10 marks for this. Okay, next one, related to acceleration. Related to acceleration part. Yes, no, this. People now, when you draw a trigonometric graph, these all points we must find. Then only we get the complete graph. Now, sometimes now, without finding this, if you draw, so the graph cut in the y-axis below the x-axis, so above the x-axis means wrong. Your graph is wrong. Okay. So therefore, these all points we need to find to get rough sketch. Right. Okay. Next one. Relative acceleration. Who got this answer for relative acceleration? Bhagya. It's very easy one. It's very easy one. Right. So most of you couldn't write one important equation by considering the length of the string. But I told you to get the answer there. The rest why you did. And it's Pakarad. Make it a trigonometry didn't do no. Right. This is how we take that now. This is angle 2 alpha. This is angle alpha. When you really do this question, all the forces you should be put in the diagram. Huh? Then only you get the full marks for the whole diagram. Right. 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 Okay. There are two strings, right? This mass m, weight mg, mass m, weight mg. Here there is a normal reaction acting on the particle S. Meantime normal reaction coming to wedge also. That also you have to mark meantime. Huh? Right. Here I'll take the normal reaction as S dash. S dash. Okay. Here we'll take the same string is this is smooth. Therefore T1 here. Right. Here this is another separate string T2. T2. Hmm? Here A. This is D. Here C. Here particle Q. Particle P. Right. Now, when the system is released, which should move to right? Hmm? Relative to which, the particle Q and particle P, particle Q should move along this phase, P along this phase. Right? Now, suppose here there is a flight. Hmm? Oh, and there is a fly at C. Looking at the motion of P and Q like this. Then it notices how this moves with certain acceleration and also meantime this with the same acceleration. Why? This and this are joined by the same light inexhaustible string. At the ends, the strings, the velocities, accelerations being the same. Hmm? Right now? Right. Then you can see there relative to the which the acceleration of this, if I take a simple f, this should also be simple f. That is relative to which. Okay. And the weight of the wedge is capital M, G. And the normal reaction I take as R. This all process we have to mark. Okay. Then I take the acceleration of the wedge relative to Earth. Acceleration is going really to right toward the. I take it as F. Here we drew T equals T, no? Okay. Then at t equals t, I measure the distance to here. Let this be x. This distance is x. And some people, they have measured. I told you, remember, whenever we use this distance measuring method to mark the accelerations, this arrowhead, hmm, this arrowhead should always be with the moving object. With the moving object. Arrowhead should always be with the moving object. Some people, they measured the distance from here to here, put in arrow here. No, this is not moving, no. Arrowhead should always with the moving object, right? Then this direction, acceleration, x double dot. Hmm? I'll take this as y. This as y. Then that is what? Y double dot. Okay. Then you can see there what? Hmm? Uh, x double dot is equal to minus f. Correct, no? X double dot is equal to minus f. Y double dot is equal to f. Expression of q. A q related to earth. Q has two expressions. F this way, capital F this way. This angle is 2 alpha, no? Q, this makes 2 alpha with the horizontal. Therefore, this is 2 alpha. And P, P is this, no? This way, F, making alpha. Okay, expression of capital M related to earth is rightward diff. Okay. Right, for the whole complete diagram, in the sense, marking all the forces and all accelerations and all important things there. You get, in this case, 30 marks. 30, yeah. Right. If you don't mark these reactions, then from this 30, you lose some marks. If you don't mark this tension, you lose some marks. If you have marked the tensions as equal of the two different strings, you lose marks. Remember. Right. So then don't draw here and there. Some people, they just here and there. If you want, you can draw near a clear one. No, don't do that. The marks come into the diagram also very important, people. Therefore, don't neglect that. Now we apply F equals MA. F equals MA. Number one, for P. mg sin alpha minus T1. This way we apply, make an angle alpha. mg sin alpha minus T1 M P. P has this, F minus F cos alpha. Number one. Right. Remember the marks come in here for this 5 marks, for this 5 marks. In this equation, for the left hand side, 5 marks, right hand side, 5 marks. Number 2, for Q, make into alpha. What do you get there? T1 plus mg sin 2 alpha. T1 plus mg sin 2 alpha minus T2. Right. m times its acceleration for q, no? Right. F minus f cos 2 alpha. F minus f cos 2 alpha. Second equation. There are also marks come in 5, left and right. 5 marks to left, 5 marks to the right. Right. Now, number 3, for the system, right word. For the system. For the system, external force is this T2. MF plus mass of Q is M. Q has the acceleration, capital F minus simple F cos 2 alpha. And P, M, F minus capital F cos alpha. Capital F minus simple F cos alpha. No? F cos 2 alpha. And this, then here you get 5 marks for this. For this, 5 marks. For this, 5 marks. For this whole equation, 15 marks come in. No? Then T2, I can write. Take this capital F terms together. M plus 2M times capital F. And take simple MF out. Then we get cos 2 alpha plus cos alpha is number 3. Okay, right. And most important equation, most of you didn't obtain. What's that? For the string this, for the string, right? This is the point E. E, C, this, E, C, Q string. This is Q, no, particle is Q. For E, C, Q string. Its range is always fixed, no? Right? Right. For E, C, Q string, X plus Y equals L. X double dot plus Y double dot equals 0 now. But what is X double dot? Minus F. What is Y double dot? F equals 0. What is this? Simple F equal capital F. Ketama పెరుగునే ketama పెరుగునే అన్న babu billa. This is number 4. Right. Here 5 marks. This is 5 marks. Right. Now this all ఎచ్చరే గాని హదం తీన్. Right. Then I'll give you the method of getting the answer. Add 1, 2, 3. Add in 1, 2, 3. What happens? Left hand side, see what happens to left hand side? Add in 1, 2, 3. Okay. Minus T1 plus T1 will cancel. Minus T2 plus T2 will cancel. Left hand side all T letters will cancel. 1 plus 2 plus 3. 1 plus 2 plus 3. Okay. Yes. All right. I'm sure that you can take the answer. 1 plus 2 plus 3. You get to left hand side something, right hand side something. 5 marks for this. I'm not going to show that simplification. Only simplification. Now, in this step, after writing this, now put for simple F, capital F, because they are equal here, no? All right. Put in that. Suppose you wrote this step, you get another 5 marks. Okay. Then that contains only what? Capital F. Subject capital F, you get this answer. Therefore, capital F, the asking answer, you get 10 marks coming. These steps you have to do again as homework. Okay, you can do, right. Now we'll go to number 5, part A. It's a small mistakes were, but in the class I did the mistake is this, show that the thrust in the light rod is 2W, not W there. Hmm? Right. Very easy one, no? That. Hmm? Very easy question. Right. Right. So equal uniform rods this way, right? Smoothly jointed to form a framework ABCD. The framework is suspended from a its square form is maintained by means of a light rod connecting the joints B and D. Square. It is now square after hanging that. So that the thrust in the light rod 2W and find reaction at the joint C. Right. So two equations, very simple one. Got that? ඒක කරන්න එපා. නිකන් බබාලා වගේ ඇවිල්ලා ගියා හරි. නේද? Okay. Right. Suspended from here. Suppose T dash square. Weights equal. A here. B here. C here. D here. Okay. System is symmetric. Therefore, reaction at C is horizontal. I take reaction this way. The thrust here we have T. We have T. Okay. Right. Then this interior angle is each 45. Yeah. 45, 45. Right. Okay. First we must write system is symmetric. Therefore, the reaction at C is horizontal. For the diagram, 5 marks. Diagram 5 marks. Write down the statement. System is symmetric. Therefore, the reaction at C is horizontal. Okay, right. We take moment around B. We take moments around B. Taking moments around B, we'll take anti-clockwise moment. X into, let us take this length as 2a. Then the distance from B to this X is what? 2a sine 45 or cos 45, both are correct. 2a sine 45. By W we get clockwise moment. That is W into a cos 45 or sine 45. A sine 45 cos 45 we can cancel down. X equals W by 2. Okay, then the moment equation we get 5 marks, answer 5 marks. Moment equation 5 marks, answer 5 marks. Now we take ABC part, for ABC part. For ABC part, we take moment around A. Say, take moment around A, we say. Huh? This W and this W both are in the same line, huh? Even though in my diagram you can't see that. 2W. Huh? Then around A, this W and this W both give anticlockwise moment. X gives anticlockwise moment. T gives clockwise moment. Huh? Right. Then we get 2W. We'll take around A anticlockwise moment. W 2W into A cos 45 plus X into this length. What's that? 2A cos 45, 2A cos 45, 4A cos 45. 4A cos 45. And T gives clockwise moment, T into 2A cos 45. Right. A cos 45, you can cancel down throughout. 2W here. X is W by 2 times 4. 2T. 2W plus 2W equals 2T. T equals 2W. This equation here, 5 marks. For this 5 marks. For this 5 marks. Final answer, 5 marks. Okay. Next paper, we have completely applied. No pure. Completely applied maths questions. Why? Some of our students, they have adapted to answer only the 2 lessons questions in pure maths. That's all for the whole paper. This time, no pure paper, only applied. All the applied lessons. All right, I have to learn before the next Wednesday. Where's the time graph? Circular motion. Work power energy. I'll tell you tomorrow. Yes. Next one, this here in the part B, question of 5 part B, that's also in the 4th line. Resting on a smooth peg given, resting on a rough peg should be there. Because if it is a smooth peg at B, we can't keep this in equilibrium, right? You see the diagram, huh? Right. A here, D here, B here, C. Right now, if this is smooth, only the normal reaction, no? We have this normal reaction, no? That should be upwards. I'm not going to mark that because we are asked to find that by using the stress diagram. Hmm? Right. And also, this AD rod is horizontal. Therefore, at the joint D along the rod, either this direction, no, this direction, we have a force. For example, suppose in the rod AD, the force is acting DA direction. Then this point D at the joint D, this D gives to the joint this way. That means the external force coming to this D should be horizontal. This direction, no, other direction. Hmm? For that, we can mark. Hmm? I have told you in this case to represent here, but to represent here the external force, just draw a line segment. Its direction we don't know. Make it a certain inclination, you can draw. But here the direction is known. So therefore, that is horizontal. This way. But I am not going to put the direction. But direction can be easily be found. Can somebody tell me the direction? When you take moment around B for the equilibrium, W gives clockwise moment. Then this external force should give what? Anti-clockwise moment. So the other force should be this way. We know the direction, but we are not going to mark that. Why? We need to find that by using the stress diagram. Okay, then here, this force, for a while I'll mark the direction. The force should be this way. Then when this B is smooth contacts do not give any friction. Because of this force acting here, this moves to leftward, the whole system. But if this is smooth, no rightward force to prevent this one. Therefore, we can't keep this in equilibrium. That is why this should be rough. Then it has horizontal component that should be equal to this and rightward. Then I'm not going to mark this way. I keep like this. Okay. Vertically also, there should be something like this. Now, for this two, there will be single resultant. For these two, there will be single resultant. That single resultant only, now I ask you to mark this way, single line. Okay. Right. So then I'll keep at the moment in this question, without this way, the single line to represent the result of these two, I'll keep the component form. So only one disadvantage when you keep this in component form, in place of one force, there are two forces. Therefore, one extra region will be increased in there. It doesn't matter in this case, very easily we can take. Okay, right. I have done the question like that. Even though you keep one single line here, that's also correct. Okay, right. Right. Okay, this way, right? This is A. And whole thing, this is B. This is C. This is D. This is E. Now we can draw the stress diagram very easily. Right. We'll come to joint C. A, B, downward W. A, B, downward W. B download W. This is 60, huh? This is also 60. Then AB download W. B is 60. Making 60. B is 60. B is 60. AE horizontal. This is E. B is 60. Then you can come to this joint A because we know this only two there. BC horizontal. CE make 60. BC horizontal. CE make 60 parallel to this. This is now C, no? Right. When you come to here, C, D should be horizontal. D, A should be vertical. C, D horizontal. D should be on this line. And when we join D and A, should be vertical. Then D should be here, no? D should be here. Then only we get right. This all. 60 here. 60 here. We get this 9. Okay. Then by CD we get this horizontal component. CD. Here. CD, no? You can see CD going this way, no? Order CD this way going. Yeah. This force is going by CD, no? The direction from CD is that way. The direction this. This is DA upward. This way. Correct, no? As we expected. What is this force? BC. What is BC? This way. Right. As we expected, all the direction correctly coming by the stress diagram. Right. Then the calculation part. Here, BE sine 60 is W. BE sine 60 is equal to W. Sine 6 root 3 by 2, no? BE 2W over root 3. But this BE length, CE length and BC length equal. Huh? BC, no, CD we need, no? Right. Therefore, we can write BE equals CE equals other one CD and other one BC. BC, do we need? Yes, BC. BC. BC, CE, BE equal to W over root 3. Okay, fine. AE we need to find. AE. AE means what? BE cos 60. BE cos 60. 2W over root 3 cos 60 is half. AE W over root 3. Right. Okay. Then this stress diagram 10 marks come in. Right. calculation of this 5 marks by using the geometry determining this equal another 5 marks. Okay. AE getting this way another 5 marks. Right. Reaction at D horizontally. Reaction at D are leftward and yes, leftward 2W by root 3. Leftward 2W by root 3 for this 5 marks. Okay. You can see this way, no? If we mark for this and this, only the resultant. There are no more two forces. Understood? When there are no more two forces, do we get this D? Region D, do we get? No. Only one line like this. No region D come in there. Then this reaction given by what? CA, no? CA. Right. The reaction given by CA. CA means what? This length. When you find that, we get what? The reaction at B. If not component form, when we take, right? Reaction at D, we found there. That's correct. Component form, we get CD. CD means this length. Horizontal component, CD this way. Vertical component, AD this way. Then how take, if you know horizontal component and vertical component, sum of the squares and root, no? It gives again what? CA, no? Okay, right. Okay, and reaction at B. At B is given by CA, right? Then CA we can write square root of W square plus CB 2W over root 3 perfect square. This gives us CA, this answer. So now 3 root W, 5 marks. But remember, you must be able to give the direction also. Direction you can mark there. The direction you can write tan theta. Okay. Tan theta. Really, CA, no? CA. That force given by CA, no? This is the angle I took as theta. This way. Tan theta is what? This divided by this, no? Tan theta W over 2W by root 3. Theta tan inverse root 3 by 2. This is 5 marks. Right, now we have to prepare the table. Right, now here tension thrust we can mark this way, right? This way. And this way, right? Okay. Now finally we can construct the table. Construct the table. We can construct the table. Right, table I think you can prepare. Okay. Table you can prepare this way. rod, magnitude, tension, thrust. BC, AC, AB, AD. Okay. Here, W over root 3, 2W over root 3, 2W over root 3, 2W over root 3. This way, we get for this table 15 marks. We get this way, that answer. Last question. I think most of the students, they have done this one, but some of them stopped at the middle. No? Not completely finished that till the last answer. Okay. We'll go to the number 6. Yes, projectile part. The particle is projected at an angle alpha to the horizontal if the horizontal range is r and the time of flight is t. Show that this answer. Very simple one. Hmm? Right. Six part A. Alpha here, r here. Time of flight given as t. S equals ut plus half v squared. You can apply upwards for the whole motion. S0. U sin alpha t minus half gt squared. This we can cancel down. T equals what? 2u sin alpha over g. For this 5 marks, this 5 marks. Take this as equation number 1. Now for the same motion, apply S equals ut rightward. Rightward. R u cos alpha t. Another 5 marks. This is number 2, 5 marks. Divide 1 by 2. This we divide by that. Left hand side we get t over 2u sin alpha over g u cos alpha. U and u you can cancel down. U cos alpha t, no? Right. We get tan alpha gt squared divided by 2r, no? For this 5 marks. Therefore, tan alpha gt squared over 2r. For this other 5 marks. Work power energy part. Motor car of mass 1200 kilogram moves on a level track. You read the question, no? Right. Part B. Wow. This car moves on the level track. Okay. Yes, its mass 1200 kilograms. Moves on a level road which produces frictional force of 1.5 newtons per kilogram. Right. If the mass is 1 kilogram, Newton 1.5 Newton friction coming. No? Then the friction force coming as what? 1200 is the total mass into 1.5 Newton. 1800, no? And maximum velocity of the motor car is 72 kilometers per hour. How to convert kilometers per hour to meters per second? Multiply by 5 by divide by 18. Maximum velocity 72 into 5 over 18 meters per second. Then there's a tractive force. Tractive force is given by what? H equals Fp, no? Right. You know, at the maximum velocity, tractive force equal to total resistance. Right. So then this force should also be what? This, no? 1800 newtons. Why? At the maximum velocity, total friction or total resistance is equal to tractive force. Asking first what? Power. Power can then be found if we know 1800 multiplied by V. 72, 18, 5. This gives 36 kilowatt. 36 kilowatt. This is 5 marks and other 5 marks here. Fine. Now next one says, now the motor car with the same power, 36 kilowatt, moves up a hill of inclination 1 is to 25. What is 1 is to 25? If the inclination of the inclination is theta, sine theta. Sine theta is 1 is to 25. That means once it rises vertical height 1 unit, it moves along the track diagonal, the hypotenuse 25 units. That's what it says. Here this is theta, sine theta, 1 upon 25. Component of weight is what? 1200 mass g weight sine theta. This way, the frictional force 1800 Newton and power H 36 kilowatt. And tractive force is there. Suppose if tractive force is F, this moves with the velocity. What is asking there? When the motor car moves with velocity 45 km minus 1, find its acceleration, not retardation. It should be acceleration. 45 kmph. The velocity is what? 45 into what? 45 into 5 over 18. Right. Okay. So in this case, by using H equals Fp, we can find the tractive force F. H means 36 into 10 to the power 3. Hmm? V, 45 into 5 over 18. Okay. So we get there something for H. So this is 5 marks. Huh? Something for this F. Now we apply F equals MA. F equals MA, we apply this way. Force is this. Hmm? This answer, when you simplify, we get F, we get for 1840. 160 into 18. We get for F in newtons. That comes here. 160 into 18 minus 1200 g sine theta minus 1800 is equal to 1200 mass. Expression is here. Yes, here we get 5 marks to left hand side, 5 marks to right hand side. Okay. So finally, when you simplify this, A comes as half. I'm not going to show the steps in simplifying. M is minus 2. It's 5 marks for here. Right. Half what? Right. The last question. The last. Oh, last part. Oh, the last. Right. Yes. Now, this is uniform speed of weight W and radius simple R is in equilibrium on a smooth inclined plane of inclination 30 to the horizontal with a string of length L. Join in the sphere and a point on the inclined plane. Show that the tension in the string is this much and find the reaction in the sphere. Right, okay. Okay. This way we have the sphere. Right. Center here. The normal reaction passes into the center like this on the sphere. That normal reaction is perpendicular to the plane. Normal reaction is perpendicular to the plane. Weight is W here. tension should be passed into the center. Reason? The space in equilibrium finally subject to the action of free forces. We know when any object is in equilibrium under the action of free forces, they must meet in a point. Yes. Here T is also T. This angle be theta. This length given as simple L. This is R. This is also R. Then this is L. Length of the string is L. Sin theta you can write there. Sin theta is of the side R, hypotenuse R plus L. Hmm? R plus L. Right. For the equilibrium of the sphere, we can resolve forces parallel to the plane. Hmm? For the equilibrium. For the equilibrium, resolving forces this direction. If this is theta, this is also theta. If I draw here, now this P is coming here, no? What is the component of T? This way, T cos theta. Hmm? T cos theta. T cos theta should be equal to what? If this is 30, parallel to the plane, what is the component of W? W sin 30. Hmm? W sin 30. Okay. For this, 5 marks. T sin 30 is half, no? W by 2. 1 over cos theta. Cos theta, right? Square root of 1 minus sin square theta. One minus sin square theta. Sin theta is this. Hmm? Right. Then it is r squared over r plus L perfect square. Okay. Okay. Substituting here 5 marks coming. Okay. And take this r plus L squared here and simplify this and take this numerator, square will vanish. Then we get the first answer. Therefore, T equals W by 2. Next answer come in R plus L divided by the square root of 2 R L plus L square, 5 marks. Asking this R, now we resolve the forces, how? Perpendicular plane, perpendicular plane. Huh? Resolving. See. Huh? What do you get there? R is equal to W cos 30 plus T sin theta. W cos 30 plus T sin theta. Hmm? W cos 30, root 3 by 2, no? Root 3 W by 2. T sin theta. Hmm? T is this answer. W by 2 R plus L divided by 2 R L plus L squared sin theta. We know R over R plus L. This and this we can cancel down, right? So here we get 5 marks. This R we get 5 marks. Okay. Then finally, take this w by 2 out. You can write root 3 plus this way, one answer coming for R. Right, for this 5 marks. Right. This is the end of the discussion.